All right, we're on to the next one here. I know that Loic and Verada are both here with us to talk about the duo of adding a proprietary key value store to Ceph as a pluggable module, as well as general support for plugin installation and upgrade. Loic, I think you had a plan here. Did you want to go ahead and just break this one down for us?
Sure. Can you hear me?
Yep.
Mm-hmm.
So we currently have two plugin systems within Ceph. It does not show because Ceph is actually shipped as a whole, but within it there are CLS plugins classes. Noha wrote a nice blog post on how to use that to implement whatever workload you want to run on a given OSD. So it's a generic plugin system that allows you to run a binary on an OSD next to the object that the OSD contains. This CLS thing is massively used by RBD, RGW to implement whatever they need. So it's kind of middleware within the OSD for the benefit of RBD or RGW. There is another plugin system, which is the Erasure Code plugin system. The infrastructure is pretty much the same. That is, we assume that there is a .so somewhere that can be DL opened, and we try to load it whenever the monitor starts or the OSD starts. But we do not handle that as a separate entity. That is, whenever you want to add a new Erasure Code plugin, you actually have to add a new feature on the OSD to say, okay, now I have a new OSD plugin. So that works to the extent that in Firefly, the Erasure Code plugins were first introduced, as well as the Erasure Code feature. So all that was a new feature. But then in Giant, we added two extra plugins, RRC and ISA, and we had to add a new feature where what we really wanted was the ability to just add a new plugin independently of the release of the OSD or the monitor. So from the beginning, we knew that we would like to have something generic, but instead of going for something generic before knowing exactly what we wanted, we went for something specific. And now we are at the point where it actually makes sense to try to think about the implementation of something that is more general purpose. What actually triggered the proposal of this blueprint is SanDisk wants to create a new abstraction for the object store, or the key value store, that would be able to load a plugin that implements this abstraction, but not necessarily shipped within Ceph. So that would be a third kind of plugin. So it seemed appropriate now to try to make an effort to generalize or to find a way to factorize all the methods to implement these plugins. What Verada will be talking about in a few minutes is a new abstraction. So I'm going not to talk about this new abstraction that will hopefully fit in the general plugin system, but rather I will try to explain how I see how a generic plugin would benefit the Erasure Code plugin system because I know it best. And there are three things actually, that I would like to discuss. First, it's the fact that when you have we have a monolithic OSD, which makes it easy for integration tests to validate that it's okay to go for the next release. And we go to a lot of tests to make sure that actually works. Not only do we deploy the OSD on multiple operating systems, but we also check that a mixed cluster introducing OSDs from a previous version and the next version will actually play well together, etc. If we introduce plugins that an OSD depends on, it means that for each plugin, we need integration tests that do essentially the same kind of validation so that we are confident that shipping the plugin to an existing cluster while upgrading one OSD after the other, one MON after the other, because the plugin may be used by the MON or the OSD. When that happens on a rolling upgrade, we want to be confident that it will actually do the right thing. So the integration tests are essential to the plugin system. You cannot think of a plugin system without thinking that for a plugin author, it is easy to trigger numerous integration tests so that when it's green, the plugin authors is confident enough that his plugin does not break something obvious. Integration tests such as unit tests, also unit tests cannot really guarantee that it will never break, but at least it shows that it does not break in an obvious fashion. The second topic is shipping the plugins. So whenever you ship a plugin, whenever you break down the OSD from one monolithic thing into an OSD plus a plugin ecosystem, then you are facing essentially the same challenges as any GNU Linux distribution, where you have a sophisticated package system with conventions on how to ensure that the shared library has the same ABI than the previous one, so you can upgrade it without changing anything. Or maybe it has a different ABI, and then it means that the major version number of the shared library changed, and then you have to also change the binaries that depend on it because they have to adapt to this new ABI. So all that culture of managing evolving packages which have different life cycles and make them manageable in the context of a stable release, that would be, for instance, the Ceph release. This is something that we do not have to invent and that we shouldn't invent. Instead, what actually makes sense to me is that we could, as plugin authors, package each plugin as a package for the target operating system. So let's say you have the SHEC plugin, which was recently contributed by Fujitsu, the Erasure Code plugin, then it would be shipped as an RPM for RHEL or CentOS, or as a .deb for Debian or Ubuntu. And whenever you want to install it, instead of pulling just a .so, you would actually call the packaging system of the operating system on which you reside. And this packaging system will not only ensure you that you match the release constraints, but also will report errors to you in a way that is familiar to any system administrators. So that's the second thing.
Sorry if I can interrupt for just a second. We punted on this a little bit in the past by just saying the .sos, like we don't worry about distribution or anything. The .sos just have to be in the right directory and they'll get loaded. And with the EC plugins, we added this additional constraint that the version string has to match exactly, so that we know that the ABI, the interface, hasn't drifted, and that the plugin will actually work. So you're saying that we essentially sort of continue doing that, but we sort of open up the possibility that we put them in a separate package where, like, the RPM for Sheck, for example, would just have a requires line that says that it has to be installed with the exact same version of Ceph OSD. Is that kind of what you're getting at?
Yes. So what I'm saying is essentially there would be a set of packages that are extracted from Ceph as it is now, with that are good citizens and have strong constraints, and they are official in the sense that, okay, we went through all the tests that we usually go through, and even to the extent that Ceph depends on these packages. So we split these packages. We have a few more packages for the Ceph plugins, but there are 4 at the moment, so it's not that many. And whenever Ceph installs itself, it also pulls them, so it will not actually disrupt anything. It will feel like it's monolithic still, but it will open the possibility that we create new packages that can have a life cycle of their own, because they rely on a mechanism that makes that possible. Where currently we rely on something that essentially requires addition of a feature every time, which is a pain, and we don't want that.
So I think that the key question, in sort of in the context of this, how packages are distributed, the one thing that I'm not totally sure about, I think what we're doing right now is we're saying that the plugin, in order to be loaded, has to have a version string that matches exactly, and that way we know that there isn't some drift in the API.
The third topic, and that's where I would like to have feedback. So the real problem, which is internal to Ceph, is how do we make sure that we can actually use that plugin in a given context. So this is different for the CLS plugin, this is different for the Erasure Code plugin, and it will probably be different for the Object Store plugin. For the Erasure Code plugin, essentially you need all OSD and all months to be able to load one plugin before you can start using it. So there must be a mechanism for the OSDs and the months to agree on a wide list of plugins that can be used. So what I proposed in the pad is a way, but I'm not entirely sure it's correct, to do that so the mechanism would be the mon receives the request to load a given Erasure Code plugin. It would, in the background, not immediately because it would take way too long, it would broadcast that to all the OSDs, and the OSDs will gradually try to install, to dynamically load the plugin, maybe fail or succeed. If they succeed, they will report back that their list of installed plugin is this, including the new plugin. And so the OSD map would have to contain, for each OSD, a list of plugins that they currently have loaded. And whenever the list, all the OSDs in the OSD map have the required plugin, then this plugin would be added to the white list of plugins that can be used to create a pool. Because there is no way for an OSD to know in which pool it will participate. So every OSD has. So that's what I imagined.
Yeah.
That seems complicated and, well.
Yes. So, I mean, we had something almost that complicated before, but it was basically solving the distribution problem, so that you would load the plugins on these are the classes at the time. You'd load the classes on the monitor, and it would store them, and then it was responsible for distributing them all to the OSDs. And it was just complicated, right? We eventually realized that, if this is what packaging systems are designed for, it's the administrator's job to make sure that the software is actually installed on every node, and not the clusters to sort of do that for you. What you're proposing is a little bit different because it's assuming that it's already installed. It's not actually not. No, it's like verifying that it's installed, but it's not actually installing it for you as loadable.
Yep.
But in my mind, it's still, if not completely, almost in the same category of a lot of complexity for something that is sort of, the job of Puppet or Ceph or something to go install the right packages.
Yeah, that's the trouble. Ideally, it's something that is done by an external tool. And whenever this external tool says to the cluster, okay, you're good to go, it's installed everywhere, then we could blindly tell to Ceph, okay, create that. Maybe we should just rely on that.
I think
it seems fragile, though.
I mean, it is fragile, but it's also a lot of work to like sort of add all the guardrails to prevent people from shooting themselves in the foot. So my inclination would be the first thing to do is just make sure that if you screw it up and you have a pool that's created with a plugin that you don't have, that you loudly complain about it by like logging into a nice central place where when things go wrong, the administrator can sort of quickly diagnose what the problem is. And as long as we do that,
okay, now
I think that's.
I thought about that, but the problem currently, what we do for a feature is that we loop over the values that were reported to the mons. If we are to check if an OSD actually is able to load the plugin as it claimed, then that seems maybe it will take a very long time. I don't see.
Well, I mean, I think we could just not do that, right? There goes the whole music again. We could just say that it's the administrator's job to ensure that it's installed everywhere, and then you go and create the pool, and if it doesn't work, it's because the admin screwed up, and there will be an error message so they can figure it out.
Do you hear the music?
Yeah.
Or just
Patrick, help.
Calling them now.
Yeah.
The leader has not yet arrived. Please stand by.
Go, Dan.
okay.
Wow, that's pretty insipid.
Yeah. They need to change their hold music like every so often.
That could be worse.
Or just, I think my favorite is the DreamHost phone system. The song that it plays when you're the only person dialed in is that song "One is the Loneliest Number," and you're waiting for the next person. I love DreamHost.
Oh yeah.
Okay. That's better. I mean, I think maybe we want to solve this problem initially, but I think the place to start with would just be to not try to solve this and just make it easy to diagnose if you screw it up. So just make a loud error message. So that if you create the pool with the check plugin and it isn't on some OSD, then that OSD will just log in the cluster log and we'll notice, right? So there's a way to the administrator to realize that they did something wrong.
Okay.
Yeah. For the other, I totally agree with number 2 that we should be distributing plugins using standard distribution tools. Like we don't want to invent our own packaging system or something. That way lies madness. For the version string, I think my inclination would be to continue doing what we're doing, where it's like a tightly coupled thing until we have a reason to relax that. But I'm less sure about that. I think if that causes a problem for somebody, then we should sort of look at that and see if it makes sense to relax. But I think the biggest thing that we actually, Oh, sorry, go ahead.
Well, I think we should continue to have that tightly coupled, but making that using packages. We'll give an example, because the problem is the developer usually is not a packager. But in the case of the plugin, the package is actually really simple if you have an example to follow. So if we do what we ship currently, but only we ship it in different packages, that will make a really easy example to follow.
Yeah. Yep. Okay. So I think that the biggest piece then, and actually the most interesting part for me is really number one, which is how do we make an infrastructure for loading plugins that's somewhat generic. And I'm not sure if this really applies to the very first set of loadable modules we did with the Veritas classes. I haven't looked at that in a long time. But in every subsequent plugin interface since then, we have this. I put this at the very bottom of the panel. There's this general pattern where you have a pure virtual class that defines your interface, and with various methods and whatever in C++ that are all pure virtual. And then there's a factory function called create that you pass the type and maybe some other random stuff that actually instantiates some implementation of that pure interface. And I think that pattern is actually something that we can make a completely generic plugin loading framework for, right? Yeah. So like the most recently with the file store, it follows this perfectly. So we just have to make it so that maybe there's a string that identifies the interface, the name of the interface. So maybe it's messenger, maybe it's file store, object store, maybe it's erasure code, EC, whatever. And then there's another string that's the name of the implementation or the type. So it's async, simple, file store, new store, whatever the actual implementation of that interface is. And then
we have a set of functions that a table of functions that completely depends on the plugin type, and that is interpreted in different. Yeah, completely agree.
Yeah, so maybe there's the init function, calls like register Ceph plugin, messenger, XIO, and then the address of my factory function, right?
Yeah.
So that registers into the central table, and then whenever you call a factory function anywhere, it just goes and looks in that registry and finds the factory, and it calls that function, and it gives you back a pointer of that type.
That's what factorize usefully.
Yeah. And I imagine that there are probably lots of projects that have done something similar to this. So, but it's also seems awfully simple. I don't know the word.
Also, one thing to keep in mind here is that these kinds of entry plugins that we've already created are all in where this kind of class-based interface makes sense. But for these dynamically loaded modules, they also have a C interface. Otherwise, it's impossible to deal with them.
Yeah, but that's
it can't be exactly the same. There has to be some extra level of abstraction for the C stuff.
Yeah, but if our plugins are using C++ interfaces, then this will just work, right? Like the plugin is built against the exact version of Ceph, so we don't have to worry about the ABI stuff so much. Right?
Well, the thing is with DL opens things, you can't really look up symbols reliably. The symbol will be if it's actually C++ interface that you're looking in, it's like some kind of horrible mangled name. You can't actually go and use things very easily with like that. You really have to have the C linkage.
Yeah. Doesn't that just where the DL open is only actually going to map one symbol or no symbols. It's just going to map the init function basically, which is going to call and register a function pointer to the factory function, and the factory function is going to provide you with an instance of that class. So I assume that the virtual method table or whatever for that class is just going to be populated by the constructor or something. Are there actually any explicit bindings that you have to do?
Well, Well, I guess you could pass everything through a void star and have everything work if it's assumed to be compiled against exactly the same version. Yeah.
Yeah. I tend to. It's easier to make a C++ API. That's what Erasure Code does currently. But the price to pay is C++ does not actually allow for a good ABI. So it's easier to make C ABI instead. And since there are only a few entry points, it's not so much of a burden. And it allows the plugin to evolve independently of the C++ class that it uses to implement the plugin. So there would be classes to implement the plugin that are C++, classes to use the plugin C functions that are C++, but they are essentially distinct. They can evolve. They can have different life cycles. Currently, the Erasure Code plugins actually compile separately the C++ files that allow them to be implemented. They are self-contained into one class. But because of the way the OSD consumes the plugin currently requires that the C++ implementation on both sides are exactly the same, then there must be an exact match of the two versions. Now, if there was a C ABI between the two, there could be slight variations in the C++ construct of the plugin while still maintaining the C ABI for the purpose of the OSD. And I find that this is desirable in general, and that in general, the plugins should publish a C ABI instead of relying on C++ non-ABI, really, because it depends on the compiler.
I mean, so just to summarize, if we do the C++ route where we only registered like the factory functions and we have this nice, then it just works. The restrictions are that it has to be the same version, like that interface can't have changed, and it has to be the same compiler version, probably.
Yeah.
Right.
It needs to be compiled by the same compiler.
Yeah. So I mean, I think that's
because we package the thing as a whole, but as soon as you start allowing plugins to come in from various sources, then you hit the problem.
Yeah. I mean that's okay that seems okay to me. Like the ease of doing the C++ linkage just makes life so much simpler. And most of the abstract interfaces that we actually want to implement with plugins are already C++ interfaces that we're specializing. So there's like no extra work except for just like building it slightly differently, pretty much. But it does mean that if you do go and build an out of tree thing, you have to make sure that you build it with the same compiler. Yeah.
That's exactly it.
And so in general, if we I mean, it means that there's one more thing for sort of out of tree downstream people to trip on, but it's kind of their problem. I guess is my general sentiment. I think that my concern with the C route is that it's just so much more work. Like the interface that we actually want to do this with first probably is the object store one. There are like 50 methods or something in that interface, and going through and defining C call points for like every single one of those calls, and then the fact that they're all buffer lists anyway, which are already sort of implementation dependent. Like it'll already screw up if different compiler versions make different inlining decisions. Probably with the buffer code, makes me think that it's just not. I don't know, Josh. You've actually gone and read all the documentation about the perils and pitfalls of C++ ABI drift.
Well, it's really a question about whether you want to be able to, whether you want to ever be able to use something that isn't compiled exactly the same time the Ceph code was.
Yeah. Well, it could be compiled by a third party after the fact. They just have to make sure it's the same.
Use exactly the same version and options, and yeah.
Yeah.
So
same platform, same libraries.
SH, so why don't you actually say write a wrapper that will actually map all those C++ interfaces that we have on the object store, and we can actually expose that simple actually POSIX API for the other object store to implement. That can be C or anything, right? So we can expose like that as well.
Sorry, could you say it again? I missed the proposal piece.
So what I'm saying is that we can have a generic wrapper of this object store that will actually load any of the object store that will implement, like say POSIX APIs, so like read, write, and all those things. That can actually be like C interfaces, right? And the wrapper that will actually will convert or will actually implement the actual object store interfaces. In that way, actually, the wrapper will be loading any interface that will be actually compliance with this POSIX interfaces like read, write, transaction, and all.
Yeah, I mean, you could do that. I think that the problem is that just puts you back into the other path where you're having to go through the pain of sort of defining the C calls for all of the different functions, and often you want to pass things around like buffer lists that are actually, complicated structures and not just like buffer pointers.
Yeah, so that interface we can define with char pointer. So the thing is that will be extra copy there. That's means char pointer to buffer list.
Sorry, you would just pass a pointer to a buffer list, is that what you said?
No, I'm saying that the wrapper will take all this buffer list and everything that Ceph understands, and actually the POSIX interface will be just C interface. Will send the char pointer and the object store, that the proprietary object store or whatever, even the file store and everything, right? So can populate that char pointer and then send it across to the wrapper. Wrapper can actually convert to the buffer list.
Yeah, you could do that too. It just means that you have this extra layer in between that's translating data structures, and it means that the main reason why we like using buffer lists in general is that you can pass around the reference counting lifecycle semantics or whatever of the buffer, so you could actually gift ownership of the buffer to the backend layer, even while you have current references, whatever, and you can bridge the two worlds basically, and you would lose that ability once you.
Yeah, so basically,
maybe it doesn't matter, but.
Yeah, eventually extra copy and all will be there. Yeah, but actually, if we are generalizing the interface, right, we cannot just expect that everybody, the other object store will understand this buffer list and all.
Yeah. Well, okay. I mean, obviously, if somebody is willing to invest that effort to translate the sort of internal C++ interface to a more forgiving C interface, is the C++ interface sufficient? Like, are the restrictions that we would place on build too onerous that you wouldn't just do what we're doing internally, essentially, with an external module and skip all of that work and have everything just sort of work seamlessly? Does that make sense? Like in your case, couldn't you do this and just be careful that when you build your proprietary plugin or whatever, that you just use the same build environment that we're using, or just ship it with packages that you built. So you build the upstream packages, and then you also build the out of tree package in the exact same environment. So you actually control the build environments.
Yeah.
Does that make sense?
Could you repeat that? I couldn't get it.
So I mean, if you use the sort of the C++ interface model that we're suggesting, where we already have a generic interface and all you have to do is make sure you build it with the same environment, and then everything just works. Like you just have to make sure the .so is built the same way that the upstream, the Ceph package was built, and all the linking and everything just works perfectly, assuming it's the same compiler version. So in that case, then is that too onerous a restriction? Like it saves a ton of work. You don't have to do any API translation stuff. You just have to make sure that it's built the same. Like,
so basically,
would that work for your use case?
Yeah. So basically, you are saying that the proprietary interfaces. Right now, our proprietary interface only knows about C stuff, and probably we're saying that we'll be writing an C++ interface that understands Ceph buffer list and everything, and actually compile with the same version that we are building with this Ceph stuff, right?
Yeah, and then you would link that to your internal library, but then you'd have one translation layer. You wouldn't have to build a second one.
Sure.
Right.
So that will be actually more specific to Ceph related stuff. We cannot just generalize that, but yeah, we can do that to actually make it more efficient, like extra copy and all will not be there.
I mean, no matter what you do, there's always going to be a Ceph plugin that's specific to whatever the Ceph interface is that glues it to your thing, right? It seems like the goal is to make it the least amount of work while not sort of putting a roadblock.
So when we are talking about a generic plugin, right? So do we really want to incorporate all this Ceph kind of layer into the generic plugin? Right. So we need some kind of an abstraction. So with the other guy doesn't need to know about any Ceph buffer list or the buffers or anything, right? So that actually breaks the abstraction just to achieve some kind of a binding towards it, right? So
sorry, say that again.
Sorry. So what I mean to say is, if you are building an abstraction, so it has to really be a more generic one, right? So it doesn't need to know anything about the Ceph buffer list or anything internal to it. So which is more like our own ref counting in the Ceph and other stuff, right? So the other guy doesn't need to really care about it. What it just want is a set of character pointers or something like that. It's kind of a table kind of thing, right?
Yeah.
So if I look at an AOA kind of way, right? So that actually beats the purpose of having a more generic infrastructure, which is more pluggable into the Ceph way. At somewhere actually we have to make a translation from Ceph buffer list to a generic interface.
Yeah.
Right. So that's where actually I feel like we are going towards, right?
Yeah. I mean, so I think there are what I'm imagining is that there would be, right, there's always going to be the generic plugin interface on the Ceph side, and there's going to be some generic storage provider thing on your side, and there's always going to be a thing that's in between, right?
Sure.
And so the goal is to have only one glue piece.
Exactly.
So either you have something that's, so that glue piece is the plugin that's going to implement the Ceph virtual interface. That can either be ideally, I guess, for the simplest thing would be that's just in tree in Ceph, and it's just a deal open on the thing. There's some licensing stuff there, so we're not sure. But so it might have to be distributed separately. But even if it's distributed separately, that just means that we need to dynamically load that piece. And I think using the C++ ABI can let you do that as long as that glue layer is compiled the same way that the upstream is.
Sure.
So there's sort of minimal effort in.
Sure. Actually, the more C-like way is more flexible here. The reason is you really don't need to care about what is a C++ backend or a C backend, right? So if you have a C ABI, you just need to say init, and internally the layer, which is actually extending the functionality, can actually deal with the other backend. Whether it can be a C or a C++ or anything, maybe in Java also. We don't need to really worry about it, right? So that's where actually I like the Loic's point. You can have a C ABI, which is actually talking to the C++ way of stuff. From the Ceph end, and you can just go ahead and then implement on your own whatever the DB backend is, right? So what it just need to know is just take a set of map options, maybe a mount option kind of thing, or open kind of options, and just do it in your internal stuff. So that kind of makes it more generic in a way. If I want to design it in a generic pluggable way. That's what I think of maybe.
Okay.
Yeah. So in that case,
I think it's very difficult to actually. I don't think it's possible to actually get rid of extra copy that Sage is concerned about. If we actually make this generic, I think that's what Sage is concerned about. But I think we will gain this more genericness. And I don't think that probably the proprietary vendors will be actually ready to means comply with the Ceph buffer list stuff, and as there will be a lot of changes on their code base as well.
Yeah.
So
yeah. I mean, I think what I mostly want to avoid is having to spend a lot of time carefully maintaining an interface. And the nice thing about the C++ virtual interfaces is it's really simple. It's just there, and it just compiles. So if we can add just the ability to dynamically load an implementation of that, then that thing that loads that can, if it wants to, it can map that to a specific C ABI, maybe my proprietary store.so, or if you want, you can map that to a generic C-based ABI if you want to go to all that effort. But I think it's not actually worth it unless you have a whole bunch of extra backends that all have the exact same interface that you're going to link in. What I would like to avoid, if we can, is having to maintain a stable C ABI, because that's a lot more work. Because we have then we're sort of on the hook to make the translation between the C++ and C stuff, and that I think that work, even if we did, you'd still have to translate our C ABI to your backend ABI. So you might as well just jump straight from our C++ one to your C one, I think. But I haven't caught up with Loic's comments, and I might have missed something. So
sure. So the other way.
No, you didn't.
No. Okay.
Sort of like.
Okay. I think he said I didn't miss anything, but I might have missed that.
Sure.
Okay.
So right now, if I actually look at the Ceph buffer list, right, it's not a contiguous kind of buffers, right? We have multiple buffers actually represented in a cat. So that actually the other backend should be able to understand if I actually kind of want to do it in a C++ way to see, and the buffer list should be able to give me a interface where that's where my buffer starts and this is my length of my buffer. Right now, to build that kind of an abstraction, I really have to do a CSTR kind of thing in the buffer list, right? So which actually does a rebuild and etc. So I don't know really can we avoid a copy there, because you still have to construct a singular buffer there and pass it on to the backend, even if it is C or C++ ABI.
Right? Yeah.
So I mean,
it's probably usually okay.
It's not only that, even if actually we maintain we'll just implement a plugin, just implement these Ceph file store interfaces, but there are a lot of this object store will maintain their own buffer stuff, right? So they require that whenever actually you send that, you use that and you free that buffer, right? So in that case also actually, even if we implement that, we have to copy to the Ceph buffer list before sending it out to upstream layer. So you cannot just reuse the buffer all the way. So for example, a read is actually populating the buffers from the proprietary store, and they expect that, okay, you get that buffer, you copy it and do a free call to my buffer list so that actually they can reuse the buffer. So that would anyway, so that we are not getting rid of this extra copy there.
Sure.
Yeah. Although I mean, in theory you could. So in practice, usually the buffers that you get are actually contiguous, so it's sort of you don't usually copy. But even if you wanted to do like a zero copy thing, you could make a specialization, a child class of the buffer raw class inside your module that understands your own internal reference counting, and then construct a generic buffer that includes those raw things, and pass that back through the C++, and it would get cleaned up properly, and then it would trigger your reference. Yeah. So I think, but this is all sort of on the side. Yeah.
Right. Yeah. It's kind of reinventing the buffer list again on top of raw again, right? So where I actually want to manage a singular buffer.
Yeah, maybe. Or maybe your backend is like mapping the flash memory directly into the host memory space, and you just want to let that go all the way up the stack and let that gets sent up. So anyway,
sure.
Maybe it makes sense to follow up this discussion on the email list, because I can't tell if we're agreeing or not. We've gone in circles.
So,
but, okay.
Right. Yeah, I would actually update the Etherpad notes with more details on this. But I actually had some notes there where I actually want to do the ADL open kind of thing and all. It's very abstract right now. We're still trying to explore how we can do better.
Okay. I mean, just to be clear, I'm not trying to like shoot holes in anybody's plans or anything.
Sure.
I'm just hoping that we can do. I want to have the minimum amount of work sort of for both parties involved, and I think there is actually a path that's easier for everyone, or easy for everyone. As easy.
Sure.
Anyway.
Yeah. So, and actually, I want to get more details on your kind of generic approach, what you are suggesting, right? So, we want to make the whole key value store or the file store, which is actually inheriting from the object store, to be more generic, right? So right now we're just talking about the key value store being a generic backend, right? So maybe.
I mean, what we're proposing right here is just to make the existing abstract interfaces, whether they're object store or key value DB, just basically make no changes to the actual interfaces except the ability to dynamically load an implementation. And I think that's easy, relatively easy. We can also evolve and change those interfaces in whatever way improves them, right? I mean, there's a big branch whip temp that's trying to simplify a bunch of stuff in object store to make it simpler, that the new store stuff is all going to be based on. I think there's a ton of stuff we can change in key value DB to make it more efficient. Like right now, everything that goes across that interface is in an STL structure, which I'm pretty sure is pretty inefficient. And I'm very happy to see patches that simplify that, or make any other changes that, given what you know about what your backend does, for example, would make it more efficient. So happy to hear any proposals to improve that.
A lot of const buffer list kind of stuff, right? So which actually involves a rebuild. Agreed.
Okay.
Right, so we're actually way over on time on this one, and I think we'll devour the break and not take a break, maybe a couple minutes, but give Josh his due, and hopefully we can catch up a little bit. Then Mike can pick up only a few minutes late.
Oh gosh, sure we are over. All right. Yeah. Sorry, Josh.
Yeah, really sorry on that. Yeah, sure. Yeah.
All right.